Hey everybody, this is a solution from day 1-7 in question 11. If you were to work your way through this, you could stumble, and I'm going to stumble in a moment. But really what I want you to focus in on at the very beginning is if my remainder is this, and we're talking about divisors of this, then I'm hoping, given a little division theory, we're good that your remainder is less than your divisor. So that satisfies that. You couldn't have taken out more. The question then says, what is the first multiple of x plus 5 greater than f of x? We may be able to very quickly, based on recognition, say, hey, if my f of x was 2 more, so not f of x equals 2, but if it was 2 more than what the old f of x was, I would have enough for another x plus 5. So really what you're looking at then is if I change that equals to a plus, that's your solution to the problem. Now, this is a little backwards from the way I normally go through things. We normally stumble our way through, and that's what I'm going to do now. So if I shrunk that down, just being cognizant of my solution is take the old f of x, make it 2 bigger, and I'll have a multiple. I want to stumble through. So I want to imagine that I'm sitting in a test situation, or I'm sitting with this problem posed right in front of me going, where do I even begin? Okay, my recommendation to you might be, if you're stumped, try to pattern it out. What I mean by that is, maybe get rid of the expressions that have variables, the unknowns, and turn them all into constants. Find the relationship with the constants and see if you can apply that to the bigger situation. So let's try it in this one. If I start off with f of x, and now I'm going to try to change every expression into a constant. Well, I've got x plus 5. How about I just make that 5? Q of x, I don't know what that is. Just make it a number. Now, you'll notice I picked 7. And the reason why I might go with something like 7 is I want to pick something that's weird. And all I mean by that is, I'm going to pick a prime number that doesn't have a lot of multiples that I work with very early. That way, I don't lose a pattern in the type of number. What am I talking about? If I made Q of x 1, well, it's probably going to hide the pattern from me because 5 times 1 is just 5. It didn't change it at all. And what I want to have happen is to change that value so I can try to find a pattern. So I don't want to lose the pattern by choosing a bad value like 1. I'm also not going to pick Q of x and make it 0 because I hope we can see that's clearly going to wipe out what we have. One of the ones that we may think is a good choice is something like 2. Picking 2 can be fine, but you have to be very careful. Sometimes a pattern is going to require you to double something versus sometimes it's going to require you to square it. And you notice that you get 4 in both of those instances. So maybe you should have squared it, but you only doubled it, and now you don't see your mistake. You don't find the pattern. So I would be very wary of choosing a number like 2. 3 is a great number to choose. Because if you start to do operations with 3, you're always going to change the value, and therefore the pattern becomes more visible. Now, the only reason I chose 7 was just to pick something bigger. I want my number to get bigger, a little bit anyway, but still functional. Okay, at the end, well, maybe if I go with that pattern that we just did, I might make my remainder 3. I just got rid of the x, made it 3. But I also had to make sure that, I'm just going to sneak that in there, that it was an 8. That would be a bad choice because now I'm eliminating all my theory. I know my remainder has to be less than my divisor, otherwise I could have divided more. So I got to make sure that whatever I chose, I'm just going to erase the whole thing. Whatever I chose for my remainder is less than my divisor. Okay, let's say we have that scenario. Now you can calculate f of x like it's no longer a mystery. 5 times 7 is 35, add on your 3 is 38. There is a numerical example of what your function notation is talking about that I just boxed in purple. So now try to answer that question with the purple. Okay, what is the first multiple of 5 that is bigger, greater than f of x, than 38? What is the first multiple of 5 bigger than 38? I hope we would be coming in on 40. Maybe just off of this one pattern, you can see how we can get back to our blue statement. Okay, the next multiple bigger than 38 of 5 is 40. Yes, but why? Well, if it is a multiple of it, then it means it's going to divide by that evenly. Its divisor goes in evenly. So I'm going to need a value that 5 goes into. The second part, though, is going to be, if it goes in evenly, then I have no remainder, which means that remainder of 3 right there has to disappear. So how can I figure that out? Well, if my remainder was not 3, but instead I put in enough to be able to take out another divisor, then really I've got a 3 there, and if there was 2 more on the end, then that would make another 5. So what I'm going to do then is I'm going to add on another 2. If I add on that 2, I don't know if you want to think of it this way, to the right side, then I have to add on that 2 to the left side. What does that make? 38 plus 2? 40. And there was the 40 that you answered just off of instinct. So, can you please zero in on that left side and notice you have 38 plus 2. Remember, 38 was your f of x. You have f of x plus 2 as your next multiple. Okay, you can get rid of all that stuff in a second. I'm going to rewind it if you need to, if you want to get any part of that down for any notes you're taking. But I now want to go up and change the question so you can see the pattern. If f of x equals x plus 5 times q of x plus 3, well, let me change that x plus 3 now to an x plus 1. Okay, what's the next multiple of x plus 5 that is bigger than f of x? Well, right now, you have a remainder of x plus 1. What do you need to do to that remainder to make it an x plus 5, the divisor? You need to add on 4 more. Therefore, you wish that f of x had another plus 4 to it to get you up to the next multiple. There you go. I'm hoping that that walkthrough gives you something to pattern, but it also reassures you, reinforces as well some division theory, us talking about divisors and quotients and remainders. Okay, I'm hoping that helps you out with problem 11. I'm hoping the rest of your practice goes well. Good luck.